Okay, now in the previous lecture we have seen the capacity of a parallel plate condenser. So that part already we have finished. Now today we are going to consider the capacitance of a parallel plate capacitor with dielectric slab between the plate. Now what is parallel plate condenser? Parallel plate condenser means there are two plates. Out of that, one of the plate has positive charge, one plate is completely charged, another plate is connected to earth. Therefore, negative charges are induced from the inner side of that metallic plate, and the spacing between that two plates is nothing but the d. So this d is nothing but the spacing between that two plates. Now, in between that two plates, I can add one of the dielectric slab. So this is my dielectric slab, and this dielectric slab has a thickness of small t. So if I add dielectric slab of thickness t, at that time what will be the capacity? That we have to consider. Clear? For that purpose. Now, what we are knowing that potential V is equal to E into D. This is our basic formula. Fine? But now, here your electric field will get divided into two parts. One is what? Electric field due to this dielectric, and another is nothing but electric field due to this remaining space. Now what is remaining space? D minus T is the remaining space. So what I say now? Potential V is equal to electric intensity due to remaining space. Remaining space is D minus T. Plus here your electric intensity, this electric intensity due to thickness as a T. So this is nothing but your total potential. This is nothing but your total potential. Now from that total potential, now we have to modify the equation. So now how we are going to modify that equation? This electric intensity, this is nothing but your E0. Why I am saying it is E0? That is due to air medium. And this E is nothing but electric intensity due to dielectric. So this is nothing but as your total V. This total V, for that total V, now I can consider this E. This E is nothing but the electric intensity due to dielectric. So that electric intensity due to dielectric I can substitute as a, here I will say it is plus E0 upon K into T. Why? Initially you have seen this formula. That in the initial case we have seen that E upon E0 is equal to K. That dielectric constant formula we have seen. So using that we have substituted here. So what I am getting here? V is equal to E0 factor is common. So inside the bracket D minus T plus T divided by K. This is nothing but your potential. This as a potential V. This is potential V, and we have a formula. In that formula, what is that? Capacity C can be written as your charge Q upon V. Now in that formula, we are going to substitute the value of V. So now we are going to substitute value of V in that place. So I am getting here as a, in this formula, if I substitute the value of V, so I can write down now same formula. C is equal to Q upon value of V is nothing but E0 into bracket T D minus T plus T upon K. Now here is nothing but your Q0. Now I am going to substitute value of E0, which you have already known. So now I am going to substitute that value of E0, which is nothing but as a, here I can say that Q upon value of E0 is nothing but Q upon epsilon 0 into A into bracket, which is nothing but as your T D minus T plus T upon K. So this value I can substitute. So now your Q factor will get cancelled. Q factor will get cancelled. Your epsilon 0 K will goes into the numerator. So now I can write this Q factor will get cancelled. You will get A epsilon 0 factor will go to the numerator, and then I can write down C is equal to A epsilon naught into T D minus T plus T upon T. In that, what is the notation? A is the area of the plate. D is nothing but the spacing between the plate. T is nothing but the thickness of the plate. And K is nothing but the value of dielectric constant. So now this I am getting as a basic formula for capacitance of a parallel plate condenser with dielectric. Now there are special cases, so this formula is important now for us. And using that formula, now we can discuss the special cases. So now what I will do, I will write this formula at the corner of the board. So C is equal to A epsilon 0 upon, in bracket, D spacing minus T thickness plus T again thickness divided by K. K is nothing but the dielectric constant. So using that formula as a basic one, now I can discuss some special cases. So in that, your first special case. What I can say that whatever this diagram previously I have drawn, that is positive charge is distributed here on the first plate, negative charge is induced on the inner side, outer side of second plate is connected to earth. And initially I have drawn this is your dielectric slab of certain thickness T. This I have drawn initially. Now what I will say, if I am saying that this dielectric slab thickness is nothing but completely which is equal to D. Means what I will say that here I can fill your complete space between that two parallel plate condenser with a dielectric constant. यहाँ पे पूरा dielectric medium मिल रहा है. So what I am getting? D is equal to T. So now I can substitute this D is equal to T. So if I substitute that one special case, first special case, that is D is equal to T. Meaning is what? The space between two parallel plates is completely filled with the dielectric constant. So what I am getting, C is equal to A epsilon 0 as it is. Here I am going to substitute now D is equal to T. So here I will substitute D plus D minus D will get cancelled. Instead of T here I am going to substitute as a D. So what I will get? D upon K. So what I will get it? A epsilon 0 K upon D. So this is my formula. If the space between the two plates will get completely filled with the dielectric constant. And what this formula? If part of the space will be filled by the dielectrics. Then next one is considering that if there are two metallic plates like this one. One plate is positively charged here. And another plate, inner side is negatively charged. And in between that, I will divide the spacing in the number of layers. And in each layer, I am inserting dielectric constant of different values. K1, K2, K3, K4 like this. Means what now? Here, the capacitors are connected in series. So like that manner now your capacitors will get connected in series. So now what will be the formula will become? So that is nothing but our second special case. So in second special case what I can say that I am going to add different dielectric of values K1, K2 up till K1. These dielectrics are connected in parallel. Therefore capacitor will act in series combination. And in series combination already we are knowing what is the formula. That is in series combination it will be nothing but 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So now your formula will become C is equal to A epsilon naught. Here I have written. And now what is the only this thing will comes into the picture because they are connected in series. Capacitors are connected in series. So instead of T1, now thickness will goes on changing. So I will say that thickness is T1. Suppose this thickness I am going to call it as T1, this thickness is nothing but T2, this thickness is nothing but T3. So according to that, this value will goes on changing. And therefore, now I will get the formula. That formula now I can write down in the format which is equal to, here this factor will get cancelled. Now your total space get divided into T1, T2, T3, T4. So I write down T1 upon K1 plus T2 upon K2 plus up till I will say that Tn upon K2. So this is nothing but your capacitor, where I can say that your capacitors, dielectric mediums are divided into spacing. Dielectrics are parallel, but such capacitors will connected in series. If reverse case will happen, what that reverse case I can say that the space will be occupied by the dielectric in the vertical manner like this one. So here is capacitor, first plate, second plate. Here is again first plate, second plate. Means all positive plates are connected together, all negative plates are connected together. So I can say this is dielectric K1 of thickness T1. This is dielectric K2 of thickness T2, like that manner. But such capacitors are connected in parallel. And you know that in parallel combination what happens? Your Cp is equal to C1 plus C2 plus C3 up till Cn. So that now it will becomes, now here what I can say that your all dielectrics will comes in parallel combination. Your dielectrics are in parallel. So number of capacitors will comes in parallel combination. So capacitors are in parallel combination. Therefore your resultant capacitance, now your resultant capacitance will goes on changing. And now your resultant capacitance can be written as, which is equal to C, you have a formula A epsilon 0. And now here your formula is what? T1 upon K1. So it will become as a, the formula will get modified into, which is nothing but as a your formula of your plate. So plate area will get divided. So I will say A1 K1 upon T1 plus A2 K2 upon T2. Like that manner I will say up till n factor. So this is nothing but your capacitance when your dielectrics are arranged in the parallel combination. And if I am saying that, sorry, here D is an array. If I am saying that area, this area will remain same. So area is same, or A1 is equal to A2 up till A, means this A1, A2 factor will get cancelled and this A factor will comes here as a same. And then your capacity will become A epsilon naught upon D is into bracket K1 upon T1 plus K2 upon T2 plus up till Kn upon T. So this is nothing but your capacity indifferently. Fine. So now this is the capacity when we have introduced a capacitance. So I will recall all the cases in that. This is the capacity when small dielectric slab is introduced. If your complete space will be filled with dielectric, your formula will become A epsilon naught K upon D if your D is equal to T. Your formula will goes on changing if you will get it A epsilon naught upon divided by, which is nothing but T1 upon K1 up till Tn upon Kn. When does this case happen? When your dielectrics are arranged in parallel. So your dielectrics are arranged in parallel combination. And last one, this dielectrics are arranged parallel but in the vertical plane. Initially you are arranging dielectric plates in horizontal plane. And now I am going to arrange your dielectrics in the vertical plane. So your formula will become A epsilon naught upon D inside the bracket. Here I can say that it is equal to nothing but T1 upon, here it will become as a K1 upon T1 plus K2 upon T2. Like that manner you will get your last factor. So in that manner you can complete your completion. Furthermore, this formula is also modified. Your T1 plus T2 all will get arranged in series. So instead of that, I can simply write it as a D. And this combination will be when your dielectrics are to be arranged in parallel combination but in the vertical. So these are the different forms. Okay, fine.